There are trillions of planets in the universe, each with very different characteristics. Some have extremely harsh climates, while others are relatively calm. Some have massive oceans, while others don't have a single drop of liquid. Some are filled with land masses, while others are simply gas giants. So why don't gas giants have any land? After all, planets form when objects within clouds of gas and dust enter each other's orbits and eventually merge over time. At least that's roughly how it happens. So today, I'm going to explain why gas giants don't have land masses and whether they could ever develop land in the future. Don't forget to like the video, subscribe to support me, and leave a comment about what the next video should be. Now, if you're ready, let's dive into a detailed introduction. First of all, throughout human history, we've looked at every light in the sky and imagined them as different worlds, wondering what they're like and what they might contain. As our technology improved, we were able to gather very detailed information, especially about the planets in our own solar system. Some are extremely hot, while others are extremely cold. Some are both hot and cold at the same time. Even within our solar system, each planet has major differences from the others. Jupiter and Saturn are considered the gas giants of our solar system, while Uranus and Neptune are classified as ice giants. Some scientists consider Uranus and Neptune as a subclass of gas giants and even see them as candidates within that category. In fact, the structure of gas giants and all other planets is determined right at the very beginning of their formation. For example, gas giants form because their cores grow rapidly and become strong enough to pull in surrounding gas with an intense gravitational force, covering themselves in thick layers of gas. At that point, a planet essentially has two possible destinies. It either becomes a small rocky planet or a massive gas giant. Today, everyone knows the fate of Jupiter and Saturn. However, many people overlook an important point. They assume gas giants don't even have a core, or if they do, that it's very small. But that's not quite true. For example, it is believed that deep inside Jupiter, there may be a rocky or icy core the size of Earth or even larger. However, this core is not like a landmass on Earth. There is no surface you can stand on. That's because above this core lies a massive atmosphere, thousands of kilometers thick, which becomes denser as you go deeper. This atmosphere may remind many people of the clouds on Earth, but in reality it resembles something closer to a hellish environment. As you go deeper, pressure increases and gases begin to behave like liquids. If you go even further down, the laws of physics begin to differ from what we are used to. For instance, quite astonishingly deep within Jupiter, hydrogen transforms into a metallic liquid state. Many people find this hard to believe, but hydrogen can indeed turn into a metallic form that can conduct electricity. This is one of the most fascinating aspects of gas giants. Things that seem completely normal from our perspective on Earth undergo extreme transformations under those immense pressures and atmospheric conditions, becoming something entirely different. So, can a gas giant lose this massive amount of gas around it and eventually turn into a core-dominated planet? Most of you probably said no, but surprisingly this is theoretically possible. Of course, it is an extremely rare and difficult process, but if there is even a 0.1% chance, we have to accept that it could happen. First of all, for this to be possible, the planet needs to get very close to its star. The intense radiation emitted by the star can gradually blow the planet's atmosphere into space. This phenomenon is known in the literature as atmospheric escape, and it is commonly observed in gas giants known as hot Jupiters, which orbit very close to their stars. However, the critical detail here is mass. Gas giants have an incredibly large mass, which means they are extremely good at holding onto their atmospheres, so even if a gas giant moves very close to its star and experiences atmospheric escape, it could take millions or even hundreds of millions of years to turn into a core planet. The pressure and atmospheric changes in gas giants are also another fascinating aspect. The reason I'm explaining this is to help you understand how powerful these planets are and why they don't easily lose their atmospheres. When you first enter Jupiter, within the first few hundred kilometers, you would see massive hurricanes, lightning, and turbulence similar to storms on Earth. But this is actually the simplest and least deadly part. As you go deeper, pressure and temperature increase, but unfortunately, this increase is not linear. As you descend, both increase, but in some regions they may double, while in others they may increase fivefold. However, the pressure difference is so extreme that the difference between Mount Everest, the highest point on Earth, and the Mariana Trench, the deepest point, becomes negligible. In comparison to Jupiter's pressure differences, it becomes almost like a child's play in comparison. You can imagine the scale of difference this way. At a certain point, due to the immense pressure, gas molecules become so tightly packed that there is no space left between them. From that point on, the concept of of gas no longer exists, and matter turns into a dense, fluid-like form. This transition point is actually a critical feature of such gas giants because it creates continuity. In other words, in a gas giant, you can never clearly say this is gas and this is liquid. There is no sharp boundary or layer. Everything changes gradually. That's why astronomers use the concept of transition regions instead of a solid surface for these types of planets. As you go even deeper, temperatures reach thousands of degrees and hydrogen molecules break apart into atomic hydrogen. At this stage, the most dramatic change occurs. The pressure becomes so immense that electrons separate from atomic nuclei and become free. This is where the metallic hydrogen we mentioned earlier begins to appear. Metallic hydrogen is extremely important for these planets because it can conduct electricity. This leads to the formation of massive electrical currents inside the planet. These currents generate incredibly strong magnetic fields. This is exactly why Jupiter has the strongest magnetic field in our solar system. Earlier, I mentioned Jupiter's core, but there's one detail I skipped. According to recent studies and emerging theories, Jupiter's core may not be a single solid rocky structure. Scientists suggest that it could be more diffuse, mixed with its surroundings, forming a dense but indistinct structure. If this is true, we may need to rethink our theories of planet formation, because it would mean that the formation of gas giants is far more complex than we previously thought. So if gas giants can, even with a very small probability, turn into rocky planets, can a rocky planet like Earth turn into a gas giant? The answer to this question is clearly no, because the formation process is crucial for a planet to become a gas giant. It needs to accumulate a massive amount of gas during its formation. However, Earth has already completed its formation and has gathered all the gas it possibly could. A more realistic question would be this: can Earth lose its oceans, land masses, and atmosphere? The atmosphere of our planet is protected by the energy coming from the sun and the planet's magnetic field. However, billions of years in the future, our star will age and expand into a red giant. During this process, the sun could destroy a large portion of Earth's atmosphere. If our atmosphere disappears, our oceans would completely evaporate and the surface would become uninhabitable. After this process, instead of becoming a gas giant, Earth would turn into a dry, stripped, atmosphere-less rocky body. Let's move on to the final part of our video and perhaps the most important question: can humanity live on a gas giant? When we talk about living on a gas giant, if what comes to mind is building structures and living like we do on Earth, this is absolutely not possible. The reason, as you can probably guess, is the absence of any solid surface. However, if we redefine the concept of living as sustaining a long-term human presence within or in the atmosphere of a gas giant, then the answer becomes far more complex and worth deeper consideration. If we divide gas giants into layers, the upper atmospheres of these planets are theoretically the most habitable regions. This is because in certain areas, pressure and temperature can reach values similar to those on Earth. For example, in the upper cloud layers of Jupiter, the pressure is approximately around 1 bar. This value is quite close to the atmospheric pressure at sea level on Earth. At the same time, temperatures in some layers can range between -100 and 0 degrees Celsius. Although these are still extreme conditions, they are not entirely lethal and could potentially be tolerated with advanced technology. The biggest challenge for long-term human presence on such gas giants is actually structural stability. Since there is no surface to stand on, any structure or vehicle designed for human habitation must continuously remain suspended and constantly adjust its position. Winds on Jupiter can reach speeds of 500 to 600 kilometers per hour. Building a vehicle that can remain stable against such forces for extended periods is not feasible with our current technology. Even if it were possible, the amount of fuel required to maintain such stability could far exceed the total energy consumption of our entire planet. This is where the concept of floating habitats comes into play. The basic principle behind this idea is actually quite simple and logical. If a gas has a lower density than the surrounding atmosphere, it will rise, just like helium balloons on Earth. In gas giants, a similar principle could theoretically allow us to remain suspended for long periods. However, there is a major problem here as well. The atmospheres of gas giants are primarily composed of hydrogen and helium. These are already the lightest known gases, making it nearly impossible to use an even lighter gas to generate sufficient buoyancy. In general, long-term human habitation on a gas giant remains extremely difficult with current technology, mainly due to stability challenges. However, as our technology and engineering capabilities advance, this may become a realistic possibility. In fact, with sufficiently advanced technology, being in the upper atmosphere of a gas giant might one day be easier than living on the surface of a rocky planet. Of course, to be certain, we will need to patiently wait for technological progress. In conclusion, my friends, gas giants can, under extremely rare circumstances, potentially evolve into rocky or core-like planets. However, this would require vast amounts of time and a very specific combination of conditions. On the other hand, our planet Earth will never become a gas giant. The same applies to other rocky planets. If you enjoyed the video, don't forget forget to like, subscribe to support the channel, and leave a comment about what topic we should cover next. Until the next video, take good care of yourselves.